Hey people, this is me answering and explaining the questions for the NEAP 2023 Unit 2 exam. Get excited. The best way to watch these videos is to have the question sheet, the actual exam with you, and also have the solutions with you, their stated solutions. I'm not necessarily going to show you each question as we go through them. I'm assuming you have it with you. All right. And as I show you the answers, as I explain the answers, a lot of people who watch these videos tend to want to jot down things next to the answers that have been given by NEAP, by the creators of the exam. So pause this video if you haven't got that sorted out yet, but if you have, let's get into it. Okay, multi-choice questions, let's get into it. Question 1, there is a graph, and I am going to show you this one because it's very visual. Excuse me. There's a graph, and one hot tip for exams is whenever you see a diagram or a graph, just takes 10 seconds to have a good look at the diagram or the graph or the picture or whatever it is. Right? You miss a lot of. Make sure that the units, for example, are what you think. That could have been hours or it could have been minutes. It is seconds, which makes it good because that's meters per second squared. That's fine. This also goes into the negative. The 0 is actually there. It's not down here. And read the title if there is one. This one doesn't have one. But it's worth just having a bit of a 10 or 15 second orientation cruise of the diagram so that you really know what you're looking at before you even attack the question. So what is the question? It says, during which time interval is the car traveling at a constant speed? Now, understand this. Constant speed means no acceleration. It's a constant speed. The acceleration has to be 0. This graph is an acceleration versus time graph. So the answer is whenever the acceleration is 0. So it's from there to there between 10 and 25 seconds. So the answer is B. Right? Big concept that. Question 2. What's the final speed of the car after the 40 seconds shown? Now this is a lot of mucking around for 1 mark. And again, I'm going to have to show you this one because you have to do it literally using the graph. So from 5, it starts at 5. Always read. A lot of people just miss that bit, right? At the very beginning of a question, especially when it's something blah, blah, blah for questions 1 and 2, people look at the diagram and they think that's the beginning. There is often something just above the diagram. A lot of people just completely miss it being there. Right, so this thing began already traveling at 5 meters per second, right? And for the next 10 seconds, it was increasing its speed by 1.5 meters per second. 1.5. So in 10 seconds, it's going to add 15 meters per second onto its speed. So by the time for 10 seconds, it started at 5, it added another 15, it's doing 20 meters per second. So its velocity, right, would be 20 meters per second. It didn't accelerate, right? Constant speed. Now we know what the constant speed is. It stayed at 20 meters per second, so it's still doing 20 meters per second there. Right? Remember, we're talking about their velocity. This is an acceleration graph. Negative acceleration is slowing down. It's decelerating. It's losing 1 meter per second each second here. Right? And it does that for 15 more seconds. So if it was doing 20 and it's lost 15 ones, which is 15, 20 minus 15 is 5. So that's what I've tried to communicate here. So its final speed, excuse me, will be 5. So the answer is B. That. Question 3 and 4 and 5 and 6 are all to do with this diagram. All right, so again, get to know the diagram first. They've described it to you here. There's a 5 kilo cart. It's moving that way at 1.2 meters per second. That's a constant velocity. Again, constant speed means something. Right? It's being pulled by a rope that's being pulled up that way direction. It isn't being pulled straight along. It is going that way, but it's pulled exactly in that direction. Right? And it's got some friction, some air resistance, whatever, that's holding it back, and the force of that is 16 newtons. Okay, that's the situation. The rope holds a tension of 24 newtons. What angle is the rope inclined above the road? So you've got to find theta. Okay, again, constant speed. Question: all the forces add up to nothing. If there's no acceleration, there's no force, right? F equals ma. Constant speed means that is 0. So that's got to be 0. Right? So all of the forces on this thing add up to nothing, which means if that's being pulled back by 16, then it's being pulled horizontally forward by 16 as well. They have to cancel each other out. And what we know is that that real force is actually 24, but the effect of it is 16 that way. So how do you figure out what that angle is? Well, you do this trigonometry down here. We've done this before. Right? If that's 24 and that's 16, what's that angle? The cos of that angle is adjacent on a hypotenuse. Solve for the angle, okay? And this is how you solve it for the angle. You've been doing that since about grade 8, 48.1 degrees. Nearest is 48, the answer is C. All right. Question 4 is really easy. What's the momentum of the cart? If you know the formula, you've got this in seconds. That's the formula. Momentum is mass times velocity, 5 times 1.26. Easy. Not even going to worry about that. Question 5. The answer is A. What amount of power is dissipated by those forces, the resistive forces, acting against the car's motion? Right. Time to know a couple of other formulas here, right? Useful for your cheat sheet. This is really useful for your cheat sheet. The work done on something is also the change in energy of something, right? So if I do 3 joules, I've lost 3 joules of energy and it gained 3 joules of energy. Right? Work and energy are both measured in joules. They can be swapped around. Force on something multiplied by the distance that it moved. Excuse me. However, power, which is what this was asking for, is how much energy you use per second. Power is how fast you can use energy. A more powerful motor can get you there, can get you both the same amount of work. One of them does it faster, right? So this is energy on time, but energy is force, right? So power is force times distance on time, and velocity is distance over time. So power is force times velocity. That is any sort of officially handed out formula sheets, but it's a handy one to know. It's a good shortcut. This question is either a 1-step, a 3 or 4-step question if you don't know that one. So it's a nice little shortcut. The power, excuse me, of being forced and it's moving a particular speed is the force times the speed. 1.16 times 1.2 in this case, watts. So the friction in the wheels, or the friction between the wheels and the road, is 10.2 joules of energy per second just to be overcome. Right? Okay, D is the answer to question 6. I don't know why I said D. I was meant to say 6. All right, in accordance with Newton's third law, which one of the following forms an action-reaction force pair with the force of the rope pulling the cart? Right. The opposite of the rope pulling the cart is the cart pulling the rope. Right? Everything is opposite in those two sentences. They've got equal things. There's a rope and a cart. They're both in there. That's equal. It's pulling. That's equal. Right? But they're opposite. Instead of the rope pulling the cart is pulling the rope. Right? Now you know where I am. So I tend to think that this is a fairly easy one, but a lot of people get this wrong. Right? Equal and opposite, if you literally write that sentence exactly opposite, right? Instead of rope pulling that, cart's pulling the rope, right? That is opposite, and it's equal as well. I haven't introduced anything else new. You're not mentioning the road, you're not mentioning the wheels. They're the same two acting on each other. Question 7, I'm just going to get that in picture a little bit better. Question 7 is about a metal sphere that's hanging from a 1.8 meter long rope or cable or whatever. Excuse me. Pole, pardon me, it's a pole. And it can be swung horizontally or vertically, and it can end up pendulum, right? And 7 said, what's the mass of the sphere? They told you that the tension when it's vertical is 2450 newtons. So we know that there's an upward force of 2450 newtons on this thing when it's hanging vertically like this, right? And it's at rest. It's not being risen up. It's not being pulled up. It's not falling down. So again, that's just another version of constant speed. Here is traveling at a constant speed of 0, right? So there's no force on it. Same thing, it goes out up to 0. So if 2,450 going up, there must be 2,450 going down. Right? Otherwise, it would be either going up or going down. Right? It'd be accelerating upwards or accelerating. So you know that that must be true. All right, and that's gravity, obviously. Right? And gravity is mg. So the force of gravity, 2450, equals m times g. That's g. Solve that for m, 250 kilos. That's it. It says, what's the mass that the sphere exerts on the pole? Now, this is when it's horizontal. There is no torque on the pole. Torque is, is the turning effect of a force. Now, when this thing's hanging vertically, like that, if it's just hanging vertically, this thing isn't trying to rotate at all. Right? It's trying to fall in a straight line. So there's no torque happening there at all. But when it's horizontal, and I've drawn it here, when it's horizontal, one point, the weight out here, the ball out here, is trying to make it rotate. Right? If it works, it's going to rotate. It's not going to fall like that because it's at the fulcrum. Right? So it's a turning effect. All right. Here's another formula you need to be comfortable with. Right? This is the formula for torque. Torque is the rotating effect of a force. It's the ability of a force to make something turn. All right, so this is trying to turn this pole around. It's trying to make it go anti-clockwise in this case. And the formula is the multiplied by the distance, or the radius, the distance that the force is acting from the fulcrum, from the center of the circle. And we've got 450 times 1.8, 4410 Newton meters. Alrighty.